Hey guys, Dusty back again with LPL. And in this video, we're going to go in depth on building this freaking chromoly 4130 gasser axle. Stay tuned, it's going to be a good one. All right guys, so what I've got on the table here, you can see, this is a Speedway axle that I had in my Nova for a little while. Anyway, so what Speedway sells is this these 2-inch. This is the heavy wall version, but it's just not super. There's a lot of guys running them, but they bend. So I am setting out to build something that doesn't bend, which enter the atomic option. So what we've got here, we've got 2-inch quarter wall. I think it's just DOM. What we got here is 2 1/4 inch quarter wall 4130. It's just kind of a side by side, a lot beefier, a lot bigger around. Well, not a lot, but you guys get the picture. And what we've got here is some 2-inch 4130, and that is because a GM Kingpin Boss, which is this apparatus right here, it is only 2 1/8 tall. And so you can't put a 2 1/8 tall Kingpin Boss on a 2 1/4 inch tube. So I need something to adapt that. So this is where this 2-inch comes into play. I've got I'll do a drawing here on the whiteboard and show you guys what's going on. Then I've got some 1.5 4130, and this is going to be the Kingpin Boss itself. So today we're going to see some lathe work, some mill work, and probably some welding. So, all right, guys. So there's some specifics that we know for a fact about going into building this axle. So one of the specifics is I'm going to use 47 to 54 Chevy spindles, car spindles. Truck spindles are a little bit different. Just stick with the car stuff. It makes life a lot easier. There's a lot more parts out there for them. So the other thing that I know is that a straight axle has kingpins. And for 47 to 54 GM spindles, the kingpins have to be tilted 4 degrees. And that's what this is showing here. So this is your Kingpin Boss. That's a 4-degree pitch. That is important because of that spindle design. The other specific thing that I know is that I want a kingpin to kingpin centerline measurement of 50 inches. That's going to give us a really close to factory track width. That all comes down to what does a guy want the car to look like. Some guys, I've seen them and I actually kind of like them, but they'll run like a 47-inch axle, and that tucks the tires up underneath the fenders. I've seen other guys that they've done a 52-inch axle, and that's closer to the outside of the fenders. Either way, with all of these factors, this is what we've got going on. So what we've got is a Kingpin Boss here. We've got our 2-inch adapter sleeve. So that's going to get sleeved into this 2 1/4 inch tube, 3 inches. And then on that tube, I'm gonna mill some slots in 4 places all the way around it. I'm gonna plug weld in these slots to that slug, as well as weld the OD right there to retain that end. The other thing to mention is when we make these and I notch for the Kingpin Boss, if you guys are doing this at home, please take this advice. Every little bit helps when we're building these axles to keep them together. And it's very possible that I am just overcritical of this, but even if you're building a simple tube axle, so if we've got a piece of tube and you're going to notch for that kingpin, Typical tube notching, the center is there, and we would hole saw this to create this fish mouth. On axles, I much prefer to have a piece of tube. And let's say in this case, this is 1.5 inch boss. So we know that 1/2 inch is 3/4, or 0.75. So I'm gonna come 0.75 back, then notch the tube. And that's gonna give us a profile like that. Here's the reason why, is when we notch this in, we have this extra area here that we can weld to. The other thing is, that is captured, that kingpin boss is captured in the end of that tube. So that, let me draw this a little better. You're going to trim it back here, but it physically can't come out without, basically spreading the end of that tube out. This is just something I like to do. I highly recommend doing it on axles. You have plenty of clearance. There's no trouble. Your kingpin set screws are going to come in here anyway, so it's just good practice to do this, and it's just to retain that end. So, all right, well, I'm going to get to cutting some material, and then we're going to come back and we'll be on the lathe. Thanks. So right now you're about 5 minutes into this video. We're going to take a quick break. I'm going to ask you to subscribe to the channel. That shows your support, and it lets us know keep making content. Every video we do, we get a little better, and man, we're having a blast doing it. So anyway, the next time you want to know how to build a gasser axle, or can I port a manifold on my trusty old Bridgeport mill, or how big of a burnout can a golf cart do, you will have seen that right here on LPL. All right, that's enough of that. We're going to get back to work. In order for all the math to work out, these need to be 5.5 inches long from tip to tail. Now, we've already set the distance from this end to the shoulder at 3 inches. Now we're going to adjust this. So we're going to adjust that in the overall length. So this is 5.582. It means we're 32 thou long. This one whew, man, we ain't got much left on that, do we? We've got 51 thousandths. Recheck that. 5.549, so 49 thou. Oh, I'm sorry. I don't know what I was smoking there. This one's got 88 left on it. $82, actually. Alright, so we're going to adjust these and face this edge back, those amounts, so that when we get these set up in the mill to do the coat, we have all the consistencies. Alright guys, so we face those. We got, see this, 5.5 inches there. And 502.5, but that's plenty close enough for what we're doing. Alright, so the next step is I'm actually going to machine the kingpin bosses. I like doing every step as we go. So I'll do all the lathe work and then all the mill work. But on these, we're going to take a cutter and cope through this, make that excellent. Alright guys, so as this is, we've got one of the kingpin boss adapters that we just machined up in the lathe. We've got one set up. So what we're going to do right out of the gate is I'm actually going to put a flat on this portion of the boss. What that's going to do is that's going to tell me that that is bottom. And by machining a flat in that right now, you know, the vise is squared up, everything's pushed down to the bottom of the vise. I'm going to put a flat in that. Then I can flip it over and I can take it in and out of the vise, you know, and I'm always going to know that it is, you know, right with the world as far as, you know, because once I adjust the angle of the spindle here, things get a little funky on trying to find where we were at. So that's what I'm going to do first. What I've got is a end mill holder with a 5/8 carbide 4-flute end mill. You don't necessarily need carbide. This isn't a hardened material if you're trying to replicate this. But I do own a machine shop, so there's some benefits of you know, having a cabinet full of surplus tools sometimes. Alright, so we've got a flat on the second one, and what we've established by doing this one right after another is we have two parts with the same depth of flat. You know, they are, for all intents and purposes, within a few thousandths identical. And the key with that is when I flip this over, all of our references are going to be the same between the two parts. When I say this is 0, that's going to be maintained. So that way we don't have some funky offset tube in the middle of these when we start to put the axle together. We want to be as precise as we can when making this part. So, just as I said, when we flop this over, that ain't going anywhere. You know, it's sturdy, it's set on that flat. And that's very important that we have that maintained. The other thing I did is I machined into that barrel a little bit, you know, by 20 thousandths. And so I have a dead stop that direction too. That's going to help us out. Alright guys, so at this point right now, we are set up. We've got the first kingpin adapter in the mill. We've got the mill head set at 4 degrees. Like we covered earlier, that kingpin boss has to go in at 4 degrees. And we are 100% centered, both in the y-axis and the x-axis over this setup here. So what we need to do now, and axis wise we're on 2 inches right here. So what we're going to do is we're going to start the cut and make a hole where there's not one. So the other thing is I use a slugger cutter for this. It's kind of a high-tech hole saw used a lot in mag drills. I know what you're thinking. Oh, you can't use that, but guess what? You can. They are super handy on a mill for doing this kind of work. So, all right, we're gonna get rolling here. Bit of advice on a cutter like this: if you're using this, you really need to make sure you got oil on it. 'Cause if you don't, it's gonna kick your ass. Nobody around here likes ass kickings. I don't know if you guys know what I just did, but as the spindle goes up and down with the head tilted, things change. So as it comes out, it would move out and in. So we can't really center anything without the length of tool that you have to use. So that being said, I use a parallel and just line up the edge of the tool with the end, so I don't get a kiss. And we're right there. Low speed and prayers. That's what this takes right here. So did you guys see the slug drop out? That is why I use those cutters. They're fantastic. So I don't want to change my setup here because I'm very, you know, it's very important to me that we don't change anything that we've done in order to make these two parts the same. So that being said, I'm just going to slide this part out slide the new one in, and I'm going to recheck that tool, and that's it. Everything else is going to stay the same except for our height. Where there was one, there is now two. All right, guys, so at this point, we're going to chuck these back up in the lathe. I've already got one in. I'm going to put a great big radius or chamfer right on the edge here and try to see if we can't make this, work these edges back a little to give us the effect that we want before we weld the bosses in. So, a little tough right now to imagine this, but when this is welded, this is going to make a lot more sense. So, now our tube is still captured because we're over center. The tube is going to extend out past this. I'm going to run a deburr over this real quick and I'll show you kind of what I'm thinking. So now we have this all worked back. The surface of the tube is in front of this. We're going to go ahead and drill the set screws there. That'll work down this other one. And then we're going to prep all of this and get to welding. So that's the look. We've got the piece of 2 1/4 inch 4130 tube set up in the lathe. And what we're going to do, I've cut that down to 46 1/2 inches long, and then I'll wind up, and that's the correct setup for the fact that I'm going to have a 50-inch wide axle. So what I'm going to do is I'm going to throw a chamfer on both sides of the tube here, on both ends, just for welding purposes, and then we'll pull it out of the lathe and we'll get ready to weld. So I've got a 3/8 4-flute carbide end mill. We're going to mill all the way through the end of this tube. The other thing I'm going to do is I'm going to take the end mill, I'm going to put a flat back here with it. That's going to mark that this is the top of the axle. And it's also going to give me a reference to come back to when I flip ends, that I can make sure that this is on the same angle as the other top, making sure that we're in alignment. Alright, so we've got a flat machined in and we've got a slot. So I can use this flat to say, hey, this is up. I could also do down, or however you wanted to do it. Either way, I know this is a reference. It was machined with this slot, and we can call this up is what we're going to do. So we've got the tube flipped around, and it's level. The main thing with this, all I did was on the flats on that end. I set a level on this end, confirmed that it was level, which it very much was. When I flipped the tube with the level in the same direction, I went to that end and reset it to level, indicating that this is straight up. All right, we're gonna get to cutting these slots, and then I'm gonna rotate them and get them busted out. When we, if you guys remember back to when we were making these, we put this flat on the bottom. So now we have a known top on our axle. And what we're going to do is we're going to machine a notch right here. It's going to allow us to line up and get right on center of our tube. Just put this little nubbin in, and by putting that in, now we have an indicator to go line up on the groove in the top of the axle that we machined in. And that indicates top because this flat was bottom. All right, so we've got our axle. We've got our nub that's been machined here. We slide this in. We can line this up and get her tacked just perfect. Right in place, and we have a good indicator of what's up, what's top. All right, so I'm gonna get this. I'm gonna finish prepping this guy for weld. I'm gonna get this all slammed together, and we'll get her tacked up and preheated and welded. All right. While this is drying, I'll walk you through some of this. So this material that we chose is 4130 chromoly, and chromoly requires some special welding most of the time. This alloy in particular, it definitely does. So what we're going to wind up doing. We're going to weld it with a standard ER70 S6. Now that's below the yield of 4130. So this is basically while we're doing this, we're just trying to make it not crack at the weld joint. So when we weld these up, we're going to preheat this material. It's very common for 4130 to preheat to around, and again, this is heavier wall material, but to preheat to around 400 degrees and not allow the inner pass temperature to exceed 600. So we want to make sure we get some heat in these parts before we start welding on. But the main reason why we want to preheat is not for the weld itself. Well, it keeps the weld from cracking. But because like this is a solid piece of material, when you weld on it, if I were to just put a weld around here, the rest of the material is going to draw all of that heat out of the weld and rapidly cool it. And that is what we're trying to prevent, so that because the rapid cooling is what's going to crack that weld. All right, guys, so this is our fit. So all of these will be filled up with weld, and it'll be welded all the way around. This is gonna be a really nice axle for the 55. The other one's all set up as well. So I'm going to set up, get the preheating. Actually, I'm going to tack these first, so nothing moves during preheat. And then we're going to get them up to temperature and get them welded. All right, guys, so we have a completed 2 1/4 inch chrome moly 4130 axle with a GM kingpin boss. We've also got kingpins that are so silky smooth. Anyway, we've got a captured kingpin boss too. This prevents, you know, just so everybody's aware, these welds are what keeps your tire on. Yeah, so that's why we want to keep this captured. I don't know if you caught that earlier or not, but anyway, yeah. And then we've got our 3-inch slug that was welded in 4 locations all around the axle. This thing turned out freaking sweet, and I cannot wait to get it installed in the car, and hopefully later in the year show you guys some action of it holding up to some huge freaking wheelies. All right, well, that's enough of that. We'll catch you on the next one. Thanks, guys.